Good afternoon, everyone, and welcome to the lecture on limiting factor analysis. What is limiting factor analysis? Anyway, we all understand that in the whole world, we do not have the resources to do just anything we want to do, all the things that we want to do. And this is a major, I think this is almost like the focal point in economic studies, taking decisions inside limiting resources, scarce resources. Right? So that thing is known to all of us. We do not have enough resources to do all the things that we have to do. And that is even more so when it comes to businesses, because we're going to analyze this situation around business environment, limiting factor analysis. So what it means actually is that organizations, business organizations, do not have all the resources that they need to do what they want to do. An organization may have an anticipated demand of this much. Or sometimes you can have almost an unlimited demand. When you produce, people will buy. But you do not have all the resources to produce all of the quantities that people will buy. And these resources that are usually in limited supply are materials, raw materials. For example, here in Ghana, you remember the situation that happened at what's this place? Where they set up the sugar producing plant. Just because there was total lack of raw materials, the plant is shut down from the time it was set up till now. Lack of raw materials or inadequate. It may be there in some small quantities, not adequate. And we see that situation everywhere in Ghana. Look at poultry. The, the quantum of poultry meat that people require in this country, all the poultry producers in this country combined cannot meet the demand. Yes, but demand is there, but they can't produce to meet the demand. And they will be limited in so many ways. Maybe they can't get enough time, enough capacity in terms of building, raw materials, blah, blah, blah. So that's how it comes about. Right. So we usually have limitations in labor hours. We can have limitations in raw materials. We can have limitations even in machine capacity. Machine capacity. Machine capacity can be in the form of machine hours. In most cases, we do not have all the labor hours that we require to produce to meet a certain demand. We do not have all the raw materials that are required to produce to meet a target demand. We do not have all the machines. And even if we have the machines can run up to a certain limit. So we may be limited in machine hours. When we have to take decisions in the midst of limiting factor, how should the decision be like for us to maximize the benefits of the situation? Okay. So that is the whole deal inside limiting factor analysis. We are going to talk about three main situations, but today I'll talk about one. But let me just introduce all the three situations that we will run ourselves through, or let's say three decision frameworks. That is better, not situation. Three decision frameworks. So decision frameworks and limiting factor analysis. That's how I am calling them decision frameworks, because we have about 3 specific situations that generate different decision frameworks. The first one is where we have only one constraint or only one limiting factor. So for example, maybe we have enough machines and machine hours, we have enough raw materials, but maybe labor hours, that's the only limiting factor. That's one limiting factor. But we are producing multiple products A, B, C, D, one or more products. So we are going to look at a decision framework where the situation is only one constraint but multiple products. That's what we'll do today. Later, we'll look at where we have 2 constraints or 2 limiting factors and multiple products. That also calls for a different decision framework. And then lastly, we will talk about multiple constraints, multiple products. The decision framework that is available for us to decide well in such situations. Today, our focus is on this one. Limiting factor analysis, where only one constraint exists, but we have multiple products. Let me just give an overview of the decision framework, but I think a question will help us understand it better. So you just listen to the general explanation of the decision framework. Where we are producing multiple products A, B, C, D, and so on and so forth. And we are constrained by one resource. The decision framework is that we have to produce. What it means is that once we have a limiting factor, what it means is that we cannot produce all the quantities that are being demanded because of the limitation, because of the limiting factor. So the decision framework is that produce in accordance with the product that has the maximum or the efficient usage of the limited resource. The product will have their own usage or how they use the limited resource. Some might use the limited resource better, some might not use it that better. So you have to prioritize the production of the 3 products around how the products maximize the use of the scarce resource. And how do we know that this product maximizes the use of the scarce resource better than this one and this one? We measure how much each product maximizes the usage of the scarce resource through the concept of contribution per limiting factor. Contribution per limiting factor. The contribution per limiting factor measures how much the product is maximizing the usage of the scarce resource in terms of contribution. So when we calculate the contribution per limiting factor for each of the products, the one with the highest contribution per limiting factor is the one that is maximizing the use of the scarce resource most, followed by the next one and the next one, and so on and so forth. So when we compute the contribution per limiting factors for all the products, or contributions per limiting factor for all the products, we rank them in order of magnitude. So first will be the one with the highest contribution per limiting factor. Second is the one that follows. Third will be the next one in that order. It means that this is the pattern by which we are going to produce the products. The one that is ranked 1 or first will be produced first. With the scarce resource, if after producing it we have some of the scarce resource or we have some of the resources left, it moves to the second rated products. So if all the scarce resources are exhausted by the production of the second product, then we don't produce the next one. So that's assumed to be the production mix or plan that maximizes our profitability, our contribution, and therefore profitability. So that's the decision framework in general. So let's take an example to buttress this. We're going to run ourselves through this example. If you have any question, you can draw my attention. So this is limiting factor analysis, and specifically one production constraint, but multiple products. So in this case, we have two products, and there is one limiting factor. But let's read the question. Sausage company. Sausage company makes two products, the mash and the sauce. Units variable costs are given as follows. Direct material cost, mash is 1 cedi, sauce is 3 cedis. Direct labor costs, mash is 6 cedis and sauce is 3 cedis. But we have information on the rate per hour. So it was rate per hour multiplied by the number of hours. That gave us 6. It means we can use this 3 and 6 to compute the hours required for the production of mash. And it is this. 3 hours, 3 cedis is paid for every hour that labor works. So 3 times a certain number of hours will give you 6. And that has to be 2. So hours that is required for the production of one mash is 2 hours. So it is these 2 hours that we multiplied by the rate per hour, 3 cedis, that give us the 6 cedis. And this one will be hours is equal to 1 hour. We multiplied 1 by this 3 cedis, and it gave us this 3 cedis as the cost. So note the simple mathematics involved in getting the hours that are required for the production of 1 unit of each of the 2 products, as I have done. All right, so we have labor cost 6 and 3 respectively for mash and sauce, variable production cost 1, giving us variable cost per unit for 1 mash to be 8 cedis, variable cost per unit of sauce 17 cedis. Let's proceed. The sales price per unit for mash is 14 cedis, and that for sauce is 11 cedis. During July, so that yellow colored information is giving us a sense of the limiting factor. During July, the available direct labor is limited to 8,000 hours. So available direct labor hours is 8,000 labor hours. This is all that we have. Whether the demand for the period July will require more than 8,000 or less than 8,000, what we have there is 8,000. And we have to compute what the demand for the period require in terms of labor hours. We put it there, compare it to the labor hours actually there, then that will make us understand whether we have a limitation in labor hours and therefore there is a limiting factor, or we don't have that. Okay, so that's just by the way. Sales demand in July is expected to be as follows. Okay, so this is how much they demand. 3,000 units of mash, 5,000 units of sauce. So once you have these units, and you also know the hours that are required for producing each one unit, you can calculate the total hours required in producing mash. And this will be, because each unit requires 2 hours. So this will give you 2 hours times 3,000 units, giving us 6,000 hours. Then for this one, each unit requires 1 hour. So this will be 1 hour times 5,000. And this will give us 5,000 hours. So for the whole period for the production of the two products, we require 11,000 hours. Good. But the question said we have only 8,000 hours. We have only 8,000 hours, which means we are short. So shortage of hours. We are short by 3,000. We are short by 3,000. So in fact, you can do it this way. You can do, so this is the hours required. Then you can do available hours. It is 8,000. So the shortage is 3,000. The shortage. So this is how you determine the limiting factor. Anyway, I am pre-solving the question. Let's read the requirement of the question. A says, determine whether labor hours represent production constraints. And B, determine the production plan that will maximize profits or contribution. Okay, so I have started solving the question halfway, but let's have a full solution screen. So A, so solution. A, determining the limiting factor. And that's what we did. So we say, so we have to calculate total hours required for production of mash and sauce in July. So we have units of production of mash is 3,000. Let's even use it. Let's even do it this way. This will be more presentable. Our aim is to calculate the total hours that is required for meeting the production level, then compare it to the hours we have. That's what I've written here. So we can say hours required for, then we can bring column here and say mash. That will be 3,000 units times 2 hours. So that will give us 6,000. Let me put the hours on top. 6,000 hours. Okay, then we have source. I think this screen is frozen. So let me try to see if another screen will work. Okay, so let me continue here. We have mash, the hours for the production. So hours for production. Mass is equal to 3,000 times 2 hours, giving us 6,000 hours. Source is 5,000 times 1 hour, giving us 5,000. I'm just repeating this. We have already calculated this, but we just want to solve it systematically according to the question. So this gives us 11,000 hours. So this is hours required. Hours required for production. Then you compare it to hours available. $8,000. You can trace this from the question. That's where I colored yellow. During July, the available direct labor hours is limited to 8,000. All right, so shortage is 3,000 hours. Okay, so this is how we determine that indeed we have a constraint. We have a limiting factor in the form of labor hours, because labor hours is short by 3,000. It's 3,000 less than required to meet the production level. Then the second requirement is determine the production plan or budget that will maximize profit. In the midst of this production constraints in the form of shortage of labor hours, what should be the production plan? And from the overview I gave you about the decision framework surrounding one limiting factor and multiple products, you have to remember that the decision framework is you prioritize the production in accordance with which product has the most efficient use or maximizes the use of the scarce resource. And we measure maximization of the scarce resource using the concept of contribution per unit of the scarce resource, contribution per unit of limited factor. So we have to kind of calculate that contribution per limiting factor so that we can come up with a table that will show us or will give us information of which product maximizes the use of the scarce resource, and therefore which product should be ranked 1, 2, 3, and so on in terms of production. So that's what we're coming to do. So we can do just this simple table. Calculation of the I'm coming. Doctor. Yes, sir. Sir. We have online lecture with just about 10 minutes time. I'll finish. Okay. Wow. Yep. What's I know about that? Yeah. Yeah. When you come, but that's it. Even you. Sorry. So we are now going to calculate contribution per the limiting factor. In this case, we know the limiting factor, so it will be contribution per labor hour. Contribution per labor hour, you understand that the formula will be equal to contribution per unit of the product divided by the limiting factor per unit of the product. In this case, it will be labor hours per unit of the product. So this is the formula for calculating contribution per limiting factor. In this case, contribution per labor hours. It is contribution per unit of the product itself divided by the labor hours per unit of that same product. Okay, so we can do a simple table like this. We can put mass here, that's our first product. Source is here. And then we first of all calculate the contribution. Contribution is calculated as sales per unit. That is in the question. Question says the sales price per unit is 14 for mash and 11 for sauce. So we pick those information. 14, 11 cedis. All of them are in Ghana cedis. Then we calculate we also find our variable costs per unit. We go back to the question that is already there. The sum of all the components, the variable cost components. So there's 8 for mash and 7 for sauce. 8, 7. When we subtract this, we get, this gives us 6 as the contribution per unit. Contribution per unit. And this is 4. So this is a contribution per unit. Now we have to go a step further to calculate. Let's go back and see the formula. Contribution per limiting factor is contribution per unit. This is the one we have just calculated. Contribution per unit. Then you have to find labor hours per unit of each of the products. When you do the division, then you get contribution per limiting factor. So we have contribution per unit. Now we have to find the labor hour, because that's the limiting factor, labor hour per unit of mass. If you go to the question, we even computed it here. 1 mass requires 2 hours, and we have to understand how we did the mathematics to know that 1 mass requires 2 hours. So that's it. 1 mass requires 2 hours. 1 source requires 1 hour. So we come here, and probably we can bring this one first. So we can now say labor hours per unit. This is 2, this is 1. And contribution per labor hour, that's the contribution per the limiting factor, is for mass is 6/2. This is 3. And this is 4/1. This is 4. Right, so this is what we are looking for the ranking in terms of which product should be produced first, followed by which. This one. Okay. So you can see that sauce has the bigger contribution per the limiting factor 4. So this will be ranked as number 1 or first, and this is second. It means that our production plan should follow this. We produce all of sources first, and the remainder of the scarce resources will now be focused on March. All right, so this is the way you calculate the contribution per the limiting factor. And then based on the values involved, you rank. And this informs your production plan. So now let's go and do the production plan. We can do a simple table that looks like this. We can have the product. So this is the production plan. So the product is here. The units to produce. Units to produce. Hours needed or required. We can bring contribution per unit, and then we can bring total contribution here. So the product, the one that was ranked first, or you can even bring rank here if you like, rank. So 1, then the product is source. Units to produce. The limiting factor, which is 8,000 hours, it can produce all of the source because one source requires 1 hour. Go back to the question. One source requires 1 hour. So we can get, and we have to produce 5,000 sources. So we can get a whole of the 5,000 hours from the 8,000. So we produce all of the sources by using 5,000 hours. So units to produce will be the total of the 5,000 units because the limiting factor can produce all of that. The hours needed is 5,000 units times 1 hour per unit, which is 5,000. So this is just actually explaining why it is 5,000 here. So let me keep it like this. And then let's focus on this one first. We'll come to write the contribution. The second rated product was March. Now the remaining hours is 3,000. How many of March can this 3,000 produce? And you have to understand why we are saying the remaining hours is 3,000. We had a total of 8 hours. We have used 8,000 hours. We have used 5,000 hours for the production of source. So 5 hours is gone out of the 8,000. The remaining is 3,000 hours. This 3,000 hours, let's go back to the question. Each mass requires 2. So the 3,000 can produce only 1,005. The 3,000 hours can produce only 1,500 of mass. Then the total hours here will be 8,000 as we had. Then we want to know so this is the production plan according to this decision framework that maximizes profitability, maximizes contribution. And so we can go ahead and calculate the associated contribution and profitability as well. So contribution per unit of source in the question, contribution per unit. Now we can get it from our calculations. So let's go back. Contribution per unit. Contribution per unit is this one. 6. So it is 4 for source and 6 for mass. So 4. It is 4 here. And 4 times 5,000 will give us 4, 5, 20, so 20,000. And this is 6. 6 times 1,500. We are going to produce 1,500 of this. This one we produce 5,000. So this times this. This times this. 6 times 1,005 will give us 9,000, giving us a total contribution of 29,000. So according to this decision framework, it is only by producing in this pattern 5,000 units of source and 1,005 units of marge that will give us the maximum contribution. Any other production mix will generate less than 2,900. And once we have a given contribution, we can determine the profit. The profit is not so necessary, it's the contribution that matter, because the fixed cost will be the same. The fixed cost will be, in this particular question, they said there's a fixed cost of, let's read it from the question. Assuming fixed cost of 20,000, assuming that fixed cost per month is 20,000, no opening stock, blah, blah, blah. So if you want to calculate full profitability by bringing in the fixed cost, which is 20,000, sorry, then our profit will be 9,000. When you use any other production plan, your profit will be less than 9,000. Okay, so this is the decision framework involving one constraint or one limiting factor, multiple products. Hope this lecture do you good in terms of making you understand the concept. Thank you very much for your time.